We've talked about parabolas in the context of just regular graphing on an x and a y coordinate system, but we're going to talk about them in a different way now, and it's all going to relate back to what we've learned before, but we're going to look at the basic definition of a parabola, like what makes something a parabola. And a parabola by definition is in blue at the top of this paper, and it says the parabola is the set of all points in a plane that are the same distance from a fixed line as they are from a fixed point, not on the line. So here we have a fixed line, and we're calling that line the directrix because in this section this is what that line is called. And the fixed point that is not on the line is called the focus. And if you take any line and any point that are configured this way, they can be angled whichever way, they can be different distances from each other, but if you take any line and any point that's on a single plane and you mark every point where that point is the same distance from the line as it is from the point, you will create a parabola. So let's look at this. So let's say we take the one right in the middle, between the focus and the directrix. We'd get this point about right here. That would be the same distance from the line as it is from the point. But that's not the only one. There's also a point out here that if you went, the distance to a point from a line is always a perpendicular distance. So notice I'll always be coming out perpendicularly from the line, because the shortest distance between a point and a line is a perpendicular distance. It lies on a perpendicular line. And we want this piece here to be congruent to this piece here. And so wherever that consistent distance is, it's about right here, that point would be equidistant from the line and the point. So this point here is the same distance as it is from the directrix as it is from the focus. So let's find another place that happens. We could take something down here and find that equal distance between the directrix and the focus, and we'd have a point about right there. We could take one out a little further like this and then have it come back down maybe like that. So this distance, this would be another point that's the same distance from the directrix as it is from the focus. Then you could come out a little farther and you start finding a different angle, and this is the same distance. This point here is the same distance from the directrix as it is from the focus. And you can continue that pattern infinitely. And what you get if you were to list every point that is the same distance from the focus as it is from the directrix, you would create this shape. And that's the parabola. So if you could just keep creating points that are the same distance from the line as they are from the point, or the same distance from the directrix as it is from the focus, you're going to get this set of points, and there's even points between these points, but you get the idea that that is going to create a parabola. So when you draw a parabola, you have a point that's related to the parabola called the focus, and you have this line that's related to the parabola called the directrix. And we've talked about an axis of symmetry before, which is the line that makes the parabola look like a mirror image on either side of the axis of symmetry. And just notice the axis of symmetry will always go through the focus. It'll go through the turning point of the parabola, which is called the vertex. And it will be perpendicular with the directrix. So the directrix will always be perpendicular to whichever way the axis of symmetry goes. And so those are some important features of a parabola in space, like on a plane, not necessarily on an x and a y axis. It's good to see the definition just kind of outside of the x and y axis and just on a flat plane. So here's another parabola going in a different direction with all of the pieces here. We have the directrix, we have the focus, we have the vertex, and we have the axis of symmetry. And another piece that we didn't talk about on the last slide is the distance between the focus and the vertex. The distance between the focus and the vertex is called the focal length, and that's usually denoted by the letter C, little c. And that distance is going to be important because it will tell us things about the equation of this parabola, as well as if you know the equation of the parabola already, it will tell you the focal length. And so we'll get into that in a minute. But whatever that distance is between the focus and the vertex has to be exactly that same distance away from the directrix. So if you go C in one direction, you'll hit the focus. If you go C in the other direction, you'll hit the directrix. And so that C length is a very important length. You'll notice in the formula of a parabola, whether it is y minus k equals a x minus h squared, or if it's the other way where you have x minus h equals a and y minus k is squared. Remember what we said about parabolas is that when the y is not squared but the x is squared, that is your up-down kind of parabola. It's either up or it's down. But when x is not squared and y is being squared, that's the sideways parabola that either goes to the left or to the right. Now, this is not a hyperbola, so that doesn't go in both directions. It just goes in one or the other, in left or right. So if you look at that, there's always an a involved somewhere in front of the x squared or the y squared term. That a is going to help us find c, because you can use the formula either direction. You can either say a equals 1 over 4c. If you already know c, you can find a. Or if you already know a and you want to find c, you just say c equals 1 over 4a. So you can go either direction. If you know c, you can find a. If you know a, you can find c. So those are two relationships that are very important, and you can use them either way. So say we had some information about a parabola, but we didn't have the parabola necessarily drawn for us. Let's say that they told us the vertex is 0, 0, just keep it simple, and they told us the focus was 0, 2, and they wanted you to write the equation of this parabola. So this parabola, because its vertex is at 0, 0, it has not been shifted left, right, up, or down, which means it is going to not have any h's or k's in them. So we're going to keep it simple, and since the focus is above the vertex, if you think about where those are, if this was the x and y axis, then if the vertex was at 0, 0, the focus would be at 0, 2, which is above the vertex. So that means the parabola has to be opening towards the focus. So the blue parabola we have is just perfect for this scenario. So you know some stuff already just from these two pieces of information. You also know what C is now because you know that the focus is 2 units above the vertex. And so C must be 2. Which means if we go the other direction 2 units, we'll end up at the directrix. So we know that the equation of our directrix, it's a horizontal line, which makes it a y equals, and we are going below the 0, 0, 2 units, so we're at -2. So that would be the equation of the directrix. The equation of the parabola, however, is going to be y equals ax squared. And we don't know what a is, but we can find it because we know what c is. And so if we take c, which is 2, and we put it into this formula, we get that a equals 1 over 8. And so what we can do is we can say the equation of this parabola is 1 over 8x squared. And since there's not an h and k, because the vertex has not moved off of the origin, we don't have to have any of this minus h or minus k stuff. We just keep the y and the x and the squared, and all we needed was figure out what a was, and we've got the equation of a parabola that has its vertex at 0, 0 and its focus at 0, 2. So this time they're going to give us the equation, and we're going to try to find the vertex, the focus, the directrix, the axis of symmetry, and sketch this parabola based off of its equation. So first thing you notice is the x is not squared, but the y is squared. And in this case, that means it's a left and right type parabola. And because the a value is negative, that means it moves in the negative direction, which is left and not right. And so we already know that the parabola is going to be this shape to the left, opening to the left. And because there's no h and k, in other words, there's nothing being added to the x and there's nothing being added to the y, our vertex is going to remain at 0, 0 at the origin. And so we know that it's going like this and that it's going to open towards the left. That's what we know so far. The other thing we can get is the focus. The focus has the letter C in it, so I always try to remember that focus has to do with the letter C. And C is found by doing 1 over 4a. And so a, in this case, is our negative 3/4. It's always the number in front of the squared term, and so negative 3/4 is our a. If we reduce that, we get negative 1/3, and that is our c value. So that tells us where our focus is going to be. It's going to be a distance of 1/3 in the negative direction away from the vertex, and so this is going to be our focus, and it's going to be at the point negative 1/3, comma 0. And so we can write that up here. What it also tells us is how far the directrix is now going to be from the vertex. The vertex is at 0, 0. The directrix will be 1/3 in the other direction away from the vertex, and so this will be the vertical line, x equals 1/3, because it's in the positive direction, 1/3. And so it's a vertical line, x equals positive 1/3. The axis of symmetry goes right through the middle of the parabola. It always is perpendicular to the directrix, and it goes through the focus and the vertex, and so it is the horizontal line, y equals 0 in this case. So to sketch our parabola, we want to keep kind of an equal distance away from the focus and the directrix at the same time, so it's going to be kind of wide like this, kind of keeping the distance that it is from the focus and the directrix about equal. And so it'll look something like that, and that's your sketch of your parabola. And all the important pieces are graphed: the axis of symmetry, the directrix, and the focus and the vertex.